Hey everyone, welcome back to the channel. If you've ever wondered how to take messy real-world data and turn it into actionable insights with Python, you're in the right place. I'm Noam Yakar, and today kicks off our brand new 10-part series on Python for data analysis, where we'll be exploring one of the most important data sets out there, the CO₂ emissions dataset. By the end of this series, you'll not only understand this data top to bottom, you'll also build a capstone project perfect for showcasing on your resume. Okay, so let's dive right into part one, the introduction to the dataset. So if you've never heard of this dataset, OWID, that stands for Our World in Data, they maintain a massive open dataset on global CO₂ emissions, covering nearly every country in the world over many decades. That means you get country level breakdowns of total CO₂ per capita, sector by sector breakdowns, and even cumulative historical totals going back to the 19th century. So this notebook is called Python for Data Analysis CO₂ Emission Series, and in today's session we'll learn what the OWID dataset is, where to get it, and how to load it into Python so we can explore its structure. By the end, you'll know exactly what each column means, how to check for missing values, and you'll have your first glimpse at the numbers behind the CO₂ trends. So let's get right into it. Okay, so I'm in this notebook here. This will be shared with everyone, so you'll be able to see and follow along if you'd like. That will be down below in the description. So let's get started. So the most important library anyone ever uses in data analysis is pandas. So we're going to import that. I'm assuming most people here have seen pandas, but if you haven't, this is the data manipulation goat, one of the best libraries for beginners. Okay, so there are many ways we can load in data sets. There's pd.readexcel, there's pd.readcsv, but today we are going to use pd.readcsv, and we're actually going to use a URL. Sometimes this can be done for local CSVs, or you can hit an endpoint. That means I can put in a URL for example, we're going to use this database from GitHub. And if that database continuously updates as you run your scripts, every time the database is loaded in, it will also update. So this is the URL, raw.github user-content.com/OWID. That's our dataset, CO₂ data, master, OWID, CO₂ data. .csv. Now if we actually go to this link, we'll actually see the CSV here. So all that this is doing is just pandas is hitting that endpoint and retrieving the CSV for us. Okay, so let's see if this works. Taking our Google Colab notebook a minute to load. And in the meantime, if you aren't subscribed, definitely hit the like and subscribe button down below. Okay, so it seems like it loaded successfully. So let's see how we might be able to explore our data set using pandas. So the easiest way to explore data set using pandas is df.head. And so we can see the first 5 lines of the data set, see all of our columns. So if we want to just specifically see columns, we can use the columns attribute. And here we see all of the columns in our data set. But I want to get a better idea of what variables we're working with. So for that, let me just write down df head here. So this, we said the first 5 rows, columns of the data set. To get more info about our data set, we could use a function called df_info. So df.info, let's just output that. So let's comment this guy and comment this guy. Okay, so we see all of the columns that we have here: country, year, ISO code, population, GDP, cement CO₂ per capita, all of these data variables. And then we see the D type as well. Object, int, float64, and we see how many non-null variables there are, which is going to be important in a minute. So when we're working with a data set, we want to work with data sets that are complete and have the most data as possible. So in the next part, I'll talk about how we can deal with missing values and how we explore distributions of variables and unique values. See you then. Okay, so let's talk missing values. So I'll open up another code tab here. So we saw previously with df_info, we were able to see for each column how many values are not null. I want to show you one more trick here. If you want to see, let's say, what are the unique values in country, in the column country, we can see all of the countries that appear in our data set. And this is very useful oftentimes when you have data with, or you want to understand the scope of the data. This tells us how many countries we have, and I think we should be able to quantify how many countries we're dealing with using the length function, and the length function tells us we're dealing with 255 countries. Now, there may be duplicates, or there may be countries that we don't know about, or sub parts of countries that are split up. For example, the US Virgin Islands. And we also see this column, upper middle income countries. Okay, Wallace and Foote, I've never heard of this country. If anyone is from this country, let me know down below. We also have continents here, North America, GCP. So what this does for us is it really sharpens how many countries we're dealing with, and also tells us that maybe the data needs to be cleaned up a little bit or reorganized. So now I want to show you guys how you might deal with null values. So first, there's this function called isNull, which just tells you if a single entry in a row is null or not. And then we can sum the null values across a column. And we see, okay, for example, the variable country has no nulls, year has no nulls, ISO code has 7,929 nulls. Population has 9,000. GDP has 35,000. And we said, how many entries do we have in the data set? df.info. Really quick, let's just recall. 50,191. Okay, so a column with like 35,000 nulls is going to be problematic. So let's go back to isNull sum. So we want to sort, let's sort how many nulls we have in descending order. So ascending equals false. And look at the top 10 most null columns. Okay, so here we see share global cumulative other CO₂ has 48,000 nulls. A similar column also has 48,000 nulls. We have some columns that have even 45,000 nulls. Now, you don't necessarily need to remove these variables from the data set. Actually, I would encourage keeping these variables in the data set because they can inform decisions often, even if there are only 2,000 rows that are non-null. My recommendation, I've said this in other videos, is to never really remove columns entirely. If you're necessarily needing to work with one specific attribute and you absolutely need to remove nulls, definitely do. But every row in a data set is valuable, so just keep that in mind. So this is how we identify how many null values are in each column and sort them. And then it's up to you, the data scientist, to decide whether you want to keep certain columns or take them out. Another useful tool you could use is df.describe. I'll show you guys what that does for us. So df.describe gives us statistics about df.describe gives us key statistics about each column. For example, the number of entries, the mean, the standard deviation, the minimum, these quantiles, 25%, 50%, 75%, and max. These are just useful values to get an idea of the distribution of the data. And when we're plotting the variables and the data, having this information is really useful, because let's say you see an outlier in the data set and you see, okay, for example, GDP or cement CO₂ per capita. I know that the mean is 0.059 and I see a massive outlier. For example, some country has a cement CO₂ per capita of 5 or 6. That's something that I want to look back to and say, okay, this country is abnormal. What's going on here? And when analyzing the data set, having these key population statistics really inform what countries in our specific scenario, what countries are producing the most CO₂, and what countries to look out for, and what countries are outliers or abnormal. So now, after identifying missing values and understanding key statistics about the data, let's see if we can visualize some global trends using matplotlib. So now we want to start visualizing global trends, and let's say we wanted to make a line plot of global emission over time. So we can use the famous library matplotlib.pyplot as PLT. Now this is just to make the library calling convention easier so that we don't have to write matplotlib ... every time we want to invoke this library. So global emissions. And if we actually look at our unique values for our columns, we'll see, yeah, world is right here. And so this technique, we're filtering a specific column. So if you see here, df, and then these two brackets, df country equals world, that's like a Boolean. So if this Boolean is true, that's the columns that we're going to get. So if we just output this global emissions head, we'll see what this looks like. Yep. So it's just countries, world. That's exactly what we want. Now we're going to plot. So global CO₂ emissions over time. We'll add an X label, year, Y label, total CO₂ emissions. And then it's always important to add a unit, so million tons of CO₂. And then we'll add a grid to make it a little bit more readable for anyone who's looking at our graph, and we'll show the graph. Okay, so now look at this graph. It's a beautiful graph, and I would say if you're starting out in data analysis, this is a great beginner sort of example of how to visualize and think about data. We want to start from a really, really broad perspective. Let's look at global CO2 emissions, and then we can ask ourselves questions. Okay, who's contributing most to these global emissions? What country is most responsible? And then we can ask questions that are more specific. Let's say we come to the conclusion that China is most responsible, or India, or the US. Then I can see, okay, what has the rate of growth been in individual country CO2 emissions, and what events have fueled growth in CO2 emissions? Like we see the Industrial Revolution, which is around here in the 1920s, fuels a huge skyrocket in CO2 emissions. I'm sure if we pinpoint the exact invention point of the car and when cars were being manufactured in mass, we would see also that fuels CO2 emissions as well. So these are the types of questions you want to think about. Let's see if we can answer our country-specific questions. So the countries that I want to look at are major global powers like the United States, China, India, and let's say Germany. So for each country, in our list countries, I want to sort and select specifically for that country. And then I want to add a plot legend, and this is going to allow us to compare emissions by country more easily. And what I really like about Google Colab is it actually gives some really useful suggestions if you're not so sure about what to write next. Thankfully, we know exactly sort of what direction we're going in, but if anyone is ever looking for a tool that does autocomplete and is really helpful, Colab, it's a Google tool. It's probably one of the best out there. Very similar in comparison to Copilot. So let's see what this gives us here. Okay, so yeah, this is a way more interesting picture. So now we're seeing global emissions by country. So interesting here, this is something I did not expect. I haven't looked at the data too much since I began recording this video. Germany's emissions have gone down as well, and India is starting to climb towards the United States. Something I definitely did not expect. So yeah, this is an interesting graph, and this allows us to ask deeper questions. Like for example, why has the United States emissions gone down since 2000? What fueled China's skyrocket from 2000 to maybe 2010? These are interesting questions. And why was Germany's emissions so low in the first place, and sort of what fueled their decline from maybe the mid 1970s to today? Really interesting questions. Well, let's say we wanted to ask a different question, maybe like emissions by fuel type. So not all CO2 is created equal. So we can ask the question, how do different fuel sources contribute to emissions globally? So in the next part, we'll take a look at that. So now let's talk about emissions by fuel type. So we're interested in a few different types of emissions, so coal, oil, and gas. So we have our global emissions variable from up here. So let's just we'll just copy that and just put that up here so we remind ourselves what that variable is. It's always important to keep track of your variables. Global emissions. So we want two different columns here. We want our year column, and then we also want our coal CO2 column. So this is a way to index multiple columns. You just do a bracket and then a bracket with two brackets with a list inside of it what columns you want to segment. So we'll do the same thing for oil CO2, and then the same thing for gas CO2. And then we're going to make something called a stack plot. And you'll see what exactly that is, but the name is pretty self-explanatory. So we have our year, and then we want three different segments. So coal will be our first. Coal CO2, and then we also want gas CO2 with labels in order: coal, CO2, oil, and gas. We want to put that here. Now, if we give the plot a legend, we just want everyone to know which is which, and the location should be, let's say, upper left. That's traditional. And we'll give the title emissions. Am I spelling that right? Emissions by fuel type, and then plot.show, and we'll see what we got. So this will generate our stack plot. Okay, so here it is. So in our stack plot, we see what is contributing most to the emissions broken down by fuel type. So it looks like gas contributes the most to emissions, while oil comes in second and coal comes in third. But you see the trend of growth after maybe World War II just skyrockets. And this actually has to be informed more by historical research to understand what trends, or even by the dot-com bubble, a huge increase of these emissions. Maybe that can be as a result of the popularity of computers, or these types of events can fuel changes in data. And that's something that you have to keep in mind as a data scientist or a data analyst, that historical events can fuel your trends in your data. So in the next part, we'll maybe take a look at per capita emissions. And so population matters. Emissions per person reveal disparities in carbon footprints across the world. And we'll see actually what countries per capita are producing the most emissions. So now into per capita emissions, we have a column called CO2 per capita. We're going to drop any null values because we don't necessarily want to deal with those for now, even though I said in the past that it's important to recognize when to drop null values and when to keep them. This drop NA is not actually changing the column, it's just changing the data that we're working with. And then we'll make a histogram of, let's say, 50 bins. Let's just see what this looks like. So this is CO2 per capita. We have no units here, we have no title here, but this is just without any null columns, a histogram, 50 bins. Now we'll add all of the title labels and see if that makes it look a little bit better. So actually, let's grab from here this. I don't want to keep writing this out. Plot title, CO2 emissions per capita, and then the Y label will be frequency. Looks a little bit better. I don't like just this massive zero. So what I'm going to do is I'm actually going to call this, I'm going to create a new variable. So I'm going to put this here and I'm going to create a variable called per cap, and we're going to do per cap.hist. What I want to do is I want to do this. I want to make it greater than 0 because I think greater than or equal. No, actually, let's do greater than 0, and then maybe our histogram will look a little bit better. Let's see here. Okay, that looks good. And then we'll do drop NA here. Let's see. Oh, wait, let's stop this because we forgot to write a crucial thing here. Stop that. So per cap, we only want CO2 per capita. We don't want all of our variables. There we go. Okay. So yeah, now that we took away anything that's less than 0, it gives us a better view of positive CO2 emissions per capita. Now, the fact that there are a bunch of zeros in the data set doesn't necessarily mean that the zeros mean nothing. There are some countries that I'm assuming the CO2 emissions per capita are very low and close to 0, and that's why it looks like it's all in the 0 bin. But this gives us a better idea of the distribution of CO2 emissions per capita without making the data completely unreadable, where all of the 0 bin is just full. So techniques like this, like maybe modifying the data a little bit or dropping some null values and looking at thresholds, even we can specify it in the title considering greater than 0. It makes it clear to the person interpreting the graph what they're looking at, and it's also very important to always specify what your graph is visualizing, because most of the time people don't see this, but they do see the graph and they want to know what it's about, and they want to be able to interpret what they're looking at. So in the next part, I'm going to be talking about correlation matrices and trend analysis, and I'll speak about that and how it relates to identifying good variables for prediction models. All right, so now we're going to talk about correlation and trends. So I'm going to show you how to build a correlation matrix using DF. So let's say we want to build a correlation matrix between GDP and CO2 per capita. So now into correlation and trends. If we want to examine, let's say, the correlation between GDP, energy per capita, and CO2 per capita, we create a variable that looks something like this. We're only filtering for those columns. And now what we want to do is let's just print out the correlation between each variable and the other variables. And that's just using the .core. Oh, capita. There we go. Okay, so here we just see a basic correlation matrix, nothing too fancy. We can either use Seaborn or Pandas to plot this in a nicer way. Obviously, each variable has perfect correlation with itself, but then we see something interesting. We see CO2 per capita and GDP have a correlation of 0.04. So these are some interesting values. I want to plot this. Now, linear correlation just means what is the relationship between variable A and variable B. So if variable A and B have a correlation of 1 or -1, that means that there is a direct linear correlation. I can plot if I plot variable A on the x-axis, variable B on the y-axis, then I can plot a straight line that measures the relationship between those two variables. So let's actually plot this correlation matrix. So we'll use plotting.scatter matrix, df core, and we'll make the figure size, let's say 8x6, and then show the plot.show. Okay, so yeah, here's correlation matrix. Now it's not like a heat map. Heat map's a little bit different, and I have many videos that demonstrate how to create a heat map. This is showing us a bar plot on the diagonal of the distribution of each variable. And then we see on the off diagonals one variable on the y, and we said there's a great correlation between CO2 per capita and energy per capita. It was like 0.72. So we see that linear relationship here in the middle grid on the very right. So this informs our data analysis. And now we're going to build some sort of predictive model. And we might use CO2 per capita and energy per capita to predict some other underlying variable. And knowing that these variables are highly correlated gives us something to use for our predictive model. So now let's say we wanted to make a predictive model like a linear regression model. So we're going to use sklearn. I have many videos, actually one video that I build linear regression from scratch. So if you want to check that out, that will be up in the cards. So we're going to import linear regression and train test split. And the more you use these libraries, this is going to be like second nature for you, like importing these libraries and these types of things. Okay, so we need to define our x variable, which let's say we want to predict CO2 per capita based on GDP, CO2 per capita. Now we want to split our data into training and testing data. Let's use some random state and invoke our model, our linear regression model, and we want to fit it on the training data. And then I want to print the r² score. That tells us how good our fit is of our linear model.score, x test, y test, and this is going to test the distance between our line and our test variable and our test data points and see if the line is a good fit. And again, if you're curious about the theory, I have many videos talking about linear regression theory. Let's see if this works. Model.fit. Oh, we have to drop null values. So let me just drop an A here and drop an A here as well. Right. Okay, so I added here a drop NA so that the number of null values would be consistent, and we would get rid of all the null values so that the shape of the data set would be consistent, so we weren't running into that error that we were running to earlier. So we fit a model to this data, and we see that the r² score is 0.64, and there are other ways that we can evaluate the regression model by looking at the sum of the squared errors of the residuals. We can look at outlier plots and all that type of stuff. I'll leave that for a different video. But for now, we fit a model to our data. We have some way to evaluate it. In the next part, we're going to talk about time series forecasting and then wrapping it up with a really nice visualization for an interactive dashboard. So here I added the time series part of the analysis. Now, a lot of this is similar information that we went over, so I'm not going to go line by line. So we have our linear regression model that we already used. We use our train test split. And then what we're basically going to do is take some of our features and that we included, like, for example, our GDP per capita, and make them into polynomial features, and then train a linear regression with polynomial variables on our polynomial data. And then we can use this prediction to do some time series forecasting of what CO2 might look like. This is some plotting information. Here is our final plot with a quadratic fit on the full history of the data. And then the orange portion is the part of the data that we predict what CO2 might be between the years of 2025 and 2039. Now, I'm not going to go directly into how to fine tune this because it does take quite a lot of fine tuning to fit a polynomial model to a time series. And there are other models like ARIMA, SARIMA models that we could use. But this is just a basic example of how we might be able to use some data. ask a question and then predict some sort of variable like global CO2 emissions and plot it in a presentable way. So the last thing I wanted to show you is a really cool visualization we can make in Plotly that takes your dashboards to a whole nother level. So here I made a visualization that shows over time how global CO2 per capita increases, and then the bubble size is population, and the color here, this scale, is the CO2 per capita. So if we press this play button, we'll see as time goes on, we'll see certain countries will start to accumulate more and more global CO2 per capita, and the population will increase. The first few years of data, we don't have so much data, but as the years go up, we'll start accumulating some more data. So we have France and Spain here, Portugal, Belgium. So let's skip to 1909. Yeah, let's start here. So you see countries like China, India, Iran start to emerge, the US as well. And if we drag the line and we keep going and going, we see more countries are showing up, like Brazil is showing up, and Colombia, and China and India are getting bigger. This is a huge, really cool tool that you can use to visualize growth over time using maps. And I think it's honestly a really cool visualization if you want to use for your portfolio to put this in some HTML JavaScript website. So the code for this is up here, and feel free to use it. It's very short, takes 2 seconds to write up. And so congratulations, you have a full Python toolkit and a bunch of libraries you can use for analyzing real world environmental data. Definitely let me know if you enjoyed this series. Stay curious and keep on coding. I'll see you guys in the next one. Peace.